Hello world, it's JWP, J Ward Primo Beats, coming to you live from my bedroom. I will be continuing along with some SynthEdit documentation, continuing along with the manual specifically. I left off at polyphony. So I'm going to switch to my desktop and open up the manual. As well, this is a rehearsal, so I'm looking at doing half hour. I'll throw my... Oop. Oh, that didn't work. What happened there? I broke it. And I spent all that time fixing this thing. Alright, the good thing this is rehearsal. It's a 320 by what, 180? What? Why is it huge? And then this was 320, this is 1600. See that over there too. Why is there two of me? Well, because there is two of me. What happened there? Yes, get over here. Okay, so I'm there. I'm there, dude. Am I there? Yes, I am. So yeah, this is a rehearsal. I will be doing, the first step. I'm going to cut this session down into half hour, I suppose. So the video, well, everything gets chopped up in the end, so videos are variable. However, the stream will still be an hour, however, it'll be the same thing twice. And this explanation won't be included next time. So without further ado, looking at what's polyphony last? Rendering to disk. Not sure if I covered this. Sure I have. Okay, so yeah, I do imagine I covered everything in this section and then I went back to polyphony. So on to tutorials and reference. I believe this is just a pop-out, tutorials and reference. Learn how to use SynthEdit with step-by-step tutorials that will guide you through building your first software synthesizer. Once you have completed that, you can progress on to more complex tasks, or learn how to take advantage of SynthEdit's powerful advanced features, such as creating VST plugins. Reference information. Handy reference information that covers everything from converting voltages to pitch on tips to recreating some classic synthesizer sounds. I need water. So this is the SynthEdit tutorial pop-up that I've demonstrated before. Signal, we've covered that. Technical specs. I don't think I covered that. Sub controls I haven't covered. Alright, so signal level conversion. Why does it feel like I've done it already? I'm gonna have to review my videos. And I'm also going to need to include more chapters. Alright. Technical specifications. If I've done this already, I apologize. I will look back at stuff and make a checklist of stuff. Technical specifications, bit depth. If you don't know what bit depth is here, I'm not going to cover it. I'll brief it. It is the depth of volume, or definition of how loud a sound can be. Not specifically loud, how defined each level of loudness is. So say 8-bit has, 8 slices. This is just an example. It doesn't actually have 8 slices. but it has 8 slices, 8 levels of loudness, or 8 levels of volume, and the audio fills to maximum volume or lowest volume, and it has 8 different chops, and so it's like 1, 2, 3, 4, 5, 6, 7, 8, and so forth. Whereas, like, say 16-bit would have 16 levels of loud volume, and 24 would have 24 levels of volume, and 32 would have 32 levels of volume. So just that's what bit depth is in a nutshell. However, 8-bit, 16-bit, 24-bit, and 32-bit, that's not the actual levels of volume there is. There's like, for 32-bit, it's quite an astronomical number. I believe it's in the millions of levels of volume. Sample rate, if you don't know what sample rate is, it is the amount of samples or points drawing the audio definition at a given second, in a given second. So, yeah, in a brief, that's pretty much it. Definition, so bit depth is this way and sample rate is that way. Looking at or perceiving audio as a two-dimensional space. Many software synths separate control signals and audio signals. Control signals, example, LFOs and envelopes, are processed at a low sample rate. This saves on CPU power, but results in sluggish envelopes and zipper noise, noticeably stepping clicks on fast envelopes, panning, or volume fades. You also have the hassle of having conversion modules. To maintain sound quality, SynthEdit uses the same high sample rate for all signals. As a result, SynthEdit just sounds cleaner and more responsive than many other soft synths, and I'm going to hide my face, as it probably might be distracting. To maintain sound quality, SynthEdit uses this high sample rate for all signals. As a result, SynthEdit just sounds more cleaner, more responsive than many other soft synths. SynthEdit supports any sample rate. The oscillator waveforms are generated to run to suit the sample rate. Non-audio signals like float and bool are event-driven. They update only when needed. For example, in the knob prefab, the patch mem float updates only when the knob is moved. This is like a variable sample rate. Float points can send at any rate up to the full sample rate. In practice, any control operated by the mouse updates at about 30 Hz or 30 times a second. Latency. I'm just going to hide my chat box for a second. SynthEdit uses either direct sound or ASIO for audio output. On a fast PC, this gives good response with low latency. When using a direct sound driver, experiment with play ahead setting to determine the best response for your PC. In other words, latency is something that computers automatically do, and the play ahead with the direct sound driver, that's just adjusting your buffer. ASIO has its own buffer, so the bigger the buffer, the more stable, but the more low latency, or the more the latency. Low latency would be a higher buffer, but less stability. So say you have a busy synth or busy effect, lots of stuff going on, there's a good chance you're going to get something called an underrun. And that's just clicking or popping, scratching, however you want to define it. And then increasing the buffer size gives a little bit of delay, so when you push the button and then the sound comes out, there's like a tiny bit of delay with the bigger buffer. However, there's more stability. It gives the computer more space to work in a second. Polyphony. So SynthEdit defaults to 6-voice polyphony. However, you can change this up to a maximum of 128 voices supported by MIDI. To access a synth's polyphony setting, right-click on it and choose Properties. I need to check my microphone. It's fine. And note VSTs control their own polyphony. See, yeah, I think we've gone through this already. Feedback loops. Tight feedback loops are not currently supported in SynthEdit, like VST. And I got my other window in the way now. Like VST, SynthEdit processes samples in blocks of about 100 samples at a time. This prevents having tight feedback loops. Feedback delay modules allow feedback at the expense of small one-block delay, usually about 2 milliseconds. See the help topic for more information. Also see the health topic. Right. That was a joke. So what is the help topic on feedback loops? Feedback paths. Okay, so this was pretty much next anyway, and since we're on the topic, might as well get into it. Feedback paths. And I didn't cover this last time. So a feedback path occurs when the output of something is returned to the input. For example, if you connect the audio out plug of an oscillator module to its pitch plug. Feedback paths are regularly used in real electronics. However, SynthEdit is a block-based environment and does not normally allow them. If a feedback path is found in a patch, SynthEdit will issue an error warning and require that you remove it before it can play sound. And then there's a picture here of this patch contains a feedback path highlighted in red. Please remove. And then it shows the two modules, main.oscillator to main.oscillator. So it looks like in the description it was the oscillator output to its pitch plug, to its own pitch plug. However, SynthEdit does have this error message where you cannot connect a module to itself using the feedback delay module. However, if you simply must have a feedback patch, if you must simply have a feedback path in your patch, you can use the feedback delay module. Insert special feedback delay. Here's a picture of the feedback delay. That's the audio one. So there is a feedback block or module for all of the DSP modules. I don't believe there is one for the it's under special, and see through this feedback. Yeah, I can see it's all rid of my chat box again. It's all DSP. So there is no feedback modules for GUI. However, I doubt it's really needed. Because of the time delay introduced by the feedback delay module, there are limitations on how you can use feedback. You can make resonant devices, a physically modeled string for example, but it won't be able to produce high frequencies due to the time delay. Why feedback paths are not allowed. This limitation is due to the way VST plugins and therefore SynthEdit process audio in blocks. A block is a group of samples representing a short piece of sound. Each block contains around 100 samples. For example, a typical synthesizer patch, the oscillator produces a short piece of sound, 100 samples long, then passes the block of samples to the filter, which then processes the block before passing it on to the next module. This carries on through the chain of modules. So it's a block of samples and going into the module and coming out. Feedback in real electronics is considered instantaneous. In a block-based system such as SynthEdit, feedback is delayed by at least one block of samples. Therefore, you cannot create a feedback path without introducing a delay at least 96 samples in length. Because of this, true feedback is not possible. So yeah, like I said, you cannot connect a module to itself anyway. However, if you do have two modules linked together and then you loop back to the first module, when you try to run the audio engine, it will warn you. So just a quick example of that. I want waveform, oscillator, and then just say a VCA quick. So modifier, VCA. And if we go audio out to signal, and everything else there is fine, we take output and we stick it in pitch, and we add some fancy little pins just to show that it's connecting to these points, and try to run. The patch contains a feedback path highlighted in red. Please remove or consider using a feedback module. See tutorials, tricks and traps in the help file. So yeah, it just turns right off. Okay, so on to subcontrols, which is a pretty big topic. And I got about 10 minutes to cover it. Introduction. Some controls provide a more customized user interface than standard controls, but require more expertise to use efficiently. They provide a lower level access to various visual elements on your control panel. Controls versus subcontrols. Controls, so we've got a picture of a control here. One of the standard controls I've demonstrated before, which comes out of controls, and that would be the slider, which is pretty much your generic all-around control besides list entry, which is here. So these are pretty static or hard-coded controls. The images, don't believe they can be customized. Perhaps if you change the graphic, it changes them. I can't remember. I don't think that is the case though. However, there is a way to change visual graphics, and that is subcontrols. Before subcontrols, SynthEdit provided only pre-made controls, like the slider control. To understand subcontrols, it is useful to understand how a control works. A slider has several interacting components. Moving the slider updates the numeric text readout and vice versa, so there is a bidirectional connection between the two subcomponents. Your computer typically updates its graphics 60 times per second, yet the control output is at audio rate signal, typically 44,100 samples per second, so there is a rate conversion happening inside the module. Your current position, well, let me explain that first. Your computer typically updates its graphics 60 times per second, yeah, so your screen is flickering at 60 times per second, or switching images 60 times per second for a typical screen. Yet the control's output is at audio rate signal, so inside SynthEdit, the audio processing is running at 44,100 times a second, so it's refreshing itself. 44,100. 44,000, no. 444? 44,100. So there is a rate conversion happening inside the module. Alright, so you can't see it running that fast, but the screen is only displaying it 60 times. The current position of the slider is stored in the patch memory. The slider will move automatically to reflect the current patch. So down here we can see a patch memory, and here's a bit of a prefab of a subcontrol. Current position of the slider is stored in the patch memory. So this, as the control is at 460 and it's in that position, with our little image here, if it was that slider, the 460 would be stored in here and not in the bitmap image. With the traditional slider, the layout of the element is fixed. There is no way, say, to put the numeric readout at the top. Okay, so it's saying that this little readout here, the number display is, you can't move that to the top. This is how it's going to look. There's no change in that. Subcontrols. The purpose of subcontrols is to, one second. Mic check. Okay, back. The purpose of subcontrols is to decompose the control into its constituent parts, into its different parts, giving you more flexibility to customize the control. Here's an equivalent subcontrol base knob. It's built inside a container module. Menu insert controls knob creates one similar one. So here we go back into SynthEdit. We'll get SynthEdit. We'll just move this stuff down, and I do believe knob is in here somewhere. Yep, right there. So this is actually a container. And in fact, let us put everything into a container. We'll just call this subcontrols demo. And we'll grab all this stuff just so we can move in here and use the new view, I suppose. And to get to the new view, or the preview of the new view, we go from the top level and hold shift, double click the container, or right click, and when highlighting this structure option or selection, hold shift and click, and then we're inside the new view. Of course it's full, which I don't want. So yeah, this knob here is actually a container, as we can see. And again, holding shift, double click to go inside, we can see all of its components. Now, if we look at this image here, well, there's a demonstration image of the container and controls on module. We can see the knob. We cannot see a panel example, but underneath it, we can see here's the internal structure, right-click structure. So in the older SynthEdits, everything was flipped. We can see that this DSP output is coming out of the right, and the GUI elements are going in from the left. Whereas modern SynthEdit actually has that the other way, and this is locked, so I can't move anything. So I'm going to right-click and more, and unclick locked, and again shift, double-click, go inside, grab everything here. By using the bounding box, hold Control, click the patch memory float to unselect it. We're going to grab everything and move it around over here. In fact, it looks like the DSP stuff is still on the right. So this prefab still kind of held the original placement of these GUI modules. How it works. 3 categories of subcontrol. The center point is the patch memory module. It handles the communication between the graphical elements. On the left with the blue backgrounds. In our case, on the right with the grayish, lighter grayish backgrounds. Teal kind of gray. I guess it'd be blue. So we'll call it bluish gray. And where am I? And the audio processing elements on the right with the gray background. Still on the right with the gray background. The float for 2 volts and the output. The patch memory module also handles any MIDI automation of the control and handles switching between presets, patches. So that's this guy here. We can see here there's the MIDI edit learn. I've covered that in the past. And the switching of presets or patches is done globally. So I've demonstrated the preset manager. However, I didn't wire one. The second type of module are graphic controls. The bitmap image and the text entry boxes. These accept user input and display the control's current value. Graphical elements use a patch memory module as a hub. Input to any object is reflected back to the others, keeping them always in sync. The third type of module here is data type conversion. For example, the text to float module. Its purpose is to bridge the patch memory. For example, the text to float module. Its purpose is to I need my chat up. Distracted. Its purpose is to bridge the patch memory module numeric float value with the text entry module, which otherwise would be used perhaps for entering a file name. You can see from the arrowheads that the graphics pins, blue background, are bidirectional. These tie in with the expected behavior. Updating a numeric entry box moves the knob and vice versa. These signals are not sampled like audio signals, but are event-driven. So the knob consumes CPU only when being moved. Compared to an audio signal, the knob generates data at a much slower rate. The signal leaves the patch memory module as an audio connection, but still at the slower rate generated by the PC's graphics system. The float to vote smooths and upsamples to a true audio rate signal suitable for driving SynthEdit's various audio modules. In SynthEdit, audio rate signals are called voltages because SynthEdit is simulating an old-school voltage-controlled synthesizer. The float to volts gives you control over how smooth the conversion should be. Less smoothing uses less CPU, but may sound stepped or zippered. The general structure of a subcontrol patch is graphical controls, bidirectional to data type converter, bidirectional to patch memory, and unidirectional to audio modules. Okay, so what this is saying, in other words, is that I don't even think that we can't see the arrows on this version. Actually, we got these small arrows, but it looks like okay. So the old view did have bidirectional. We can see each side of the arrow has an arrow, has a triangle, I guess, and then on the DSP side, the arrow only goes one way. In the new view, however, we have 0 arrows. Well, we have the one arrow in the middle. There's not one going either, are they? In other words, then, these two guys are constantly communicating to each other. However, they're communicating to each other on a frames per second rate. So I'm not exactly 100% sure what the rate is. I do believe it said 60 hertz. Imagine it's following your screen frames per second. So if you're running 60 frames per second, then these are communicating between each other at 60 frames per second. Can I get one to respond? There we go. So yeah, that's happening at 60 frames per second. However, it's converting to audio at the 44,100. So the stuff that's coming out of here, which is only going in one direction, is coming out at 44,000. So if something happens downstream, say you change something, you have a, can even use a slider as an example. It's one-way flow. Anything that happens after this point won't change the patch memory float. Everything that needs to be changed between changing values has to happen here. And although they are bidirectional, you can only plug. You can do multiple plugs, say on this these pins on the right, but you cannot do multiple plugs on the left. So say if I had 2 patch memories, well, I just demonstrated that I can have 2 controls, so these 2 shiny knobs are controlling the same patch memory, but they can be different places on, say, your GUI. However, you can't have 2 patch memories connected to the shiny controls. This type of plug only accepts 1 plug. So you can't control 2 patch memories with 1 knob, but you can control 2 knobs with 1 patch memory. I know it seems straightforward, or it may seem straightforward. However, down the road, once you get into things, it can be a bit of a nuisance. It can be something you need to consider. Customizing. You can see that numeric input is optional. You can just delete it if you don't need it. Same with the rotating knob image. Actually, before moving on, I should also mention that coming back into the GUI realm, you do not want to process using GUI because it is slower. Like I said, it's only running at your frames per second. So if you're going to be processing DSP audio, always do it in the DSP realm. Maybe a bit more of a intermediate conversation. But yeah, always process audio in audio. You can do some GUI processing in the DSP realm. However, it is inefficient. It's only if you absolutely have to. So again, that's an intermediate topic. Something to watch out for. Okay, customizing. You can see that the numeric input is optional. Just delete it if you don't need it. Same with the rotating knob image. You can now place elements however you like. Arrange everything horizontally, for example, or by opening the knob's panel view and dragging the subcontrols. Okay, so this is where we get a little more advanced with, well, not advanced, but this is kind of the next step of subcontrols. So we're going to go to panel edit. We can see our knob here. And as it said, the numeric display is optional. So we can see that we don't actually have a numeric display. However, we do have our title, and we have the different elements of the knob. We have the shiny thing and the collar or the rib around the knob, and we have the indicators, which are unlegible. They're a little bit legible, I guess. And we can click it and go from 0 to 10. And we can also move things around individually. So we can grab this guy. I'm going to start here because if I grab one of these, it's going to fall apart. Because there's 3 different elements there, but also I'm going to start with the title, and we'll put the title on top. So this knob is named knob. And in order to change it from knob, we go into the text entry, and we can see here text knob. So we'll call this control instead. And we go back into panel, and we can see that everything disappeared. So I don't know what's going on there. Let's try that again. Panel edit. Okay, everything's back. Don't know what happened there. It is now called control. So say we want a numeric readout. Maybe that'll be covered No, it won't be covered. So I'll cover that right quick. If we want a numeric readout, I'm going to just copy this text entry, go right click copy and click somewhere else, right click paste. Now I have 2 text entries. However, I need the value output, which range here. The patch memory has a range for the control. For now, I'm just going to leave that to 0 to 10. And that is a numeric value. However, it's coming out of a float, patch memory float, so I need to convert that. And it's not in the DS. This is the DSP conversion package. So I need to go to, get rid of my chat box. Going into subcontrols, we have another conversion package, and I want to convert from floats to text. If I try to connect directly from float to text, from value to text entry, cannot connect these plug types directly. Example, you cannot connect a voltage pin to a file name. Consider using a converter module, which we are going to do. So we go to float to text, and we'll throw that way up here. Move this down a bit, and we'll go from a value into float value, and it has a decimal places point, and text value out into text. Now it'll reprogram the text entry to whatever the float value or patch memory float is holding, and whatever the knob is telling it to hold. All right, and decimal places here, -1 will automatically create a decimal place if need be. And if we go 0, we have no decimal places. And if we go back to this module and change to, say, 5, we get 5 decimal places. However, going into -2 or negative whatever, in the past will crash SynthEdit, so don't do that. Take a word from an experienced person. Do not try to go -2 or 3 decimal places on the float to text conversion module GUI. Because in the past it has crashed SynthEdit. I don't know what to do. Now I don't want to try. Back to subcontrols. New pins in SynthEdit version 1.1. So it looks like hint provides for tooltips the pop-up yellow box that appears when you mouse over the control. So there is the hint here, and this is programmed through a subcontrols patch memory text. Keep in mind that the more patch memories you have, the slower it will take to save, and there is a ultimate point where saving is not possible, but we're talking like thousands of modules. I once built a concept piece called 100x oscillator, and after a certain point, I just couldn't save it anymore. So yeah, keep in mind, limit how many patch memory floats you have. In this situation here, I will be just typing whatever. So we'll call this a demonstration control. Put a period there, full stop, or that's the name rather. I want that in the value position, right? Yes. Make sure to hit enter, otherwise it will not show. And why? Oh, okay, because I put that in text, that's why. I want that in hint. Oh, and I got a crash. Yay! Alright, let's reopen SynthEdit. So maybe there's something buggered about that. So I'm just going to finish up with the subcontrols right quick. In fact, because this was the rehearsal, I'm going to end it here. So the idea for the rehearsal is just to get warmed up and make sure everything is running. And I will be back shortly. Just going to show up the bumper screen. I will be back shortly to lay in the final production, I suppose it can be called. So yeah, until next time.